Well, it'll take a little bit, but not too long. Okay, so we're going to do, these are the things we're going to do. Collapsing sums. Tomorrow we'll do the proof the harmonic series is convergent, if you would like to see that. And then some questions. So we're skipping example 4. Did you find the worksheet salmon colored? Salmon. Okay, we're going to do this one. First we'll do this problem, and then we'll do the collapsing sums. And we have another convergence test because of the collapsing sums. Okay, are we ready? Can you see that, or should I need to close the blinds? Yeah, I can turn that too. Okay. Does anybody recognize what kind of series that is? What is a series? The addition of the terms in a sequence. And this is what? This is geometric. You see that this is geometric? It's an exponential. And if you don't see it, you can write it out. Now this is an interesting one that we're going to come back to. So if I let n equal 0, it's x to the 0 plus x to the first plus x to the second plus x to the third plus x to the n. That's what the sum is. It's a very special one. It's geometric. And we have lots of things that go with it, David. I've already done the chapter, so I can see ahead. Now, if x is bigger than 1, will that converge? No. But if x, absolute of x, is less than 1, it will converge because it's geometric, and what's the common ratio? You're multiplying by what? You're multiplying by x. So r is equal to x. So what's the formula? If it's a convergent, if it's geometric series, it's s equals a over 1 minus r. What's a? No, careful. It's x to the 0, so it's 1. And what's r? X. So this will converge to 1 over 1 minus x. And you're saying, so what? Now that's provided that the absolute value of x is less than 1. Then I think this is where it gets to be kind of interesting. What this is saying is that this rational function, 1 over 1 minus x, provided that x is a fraction between 1 and negative 1, is equal to 1 plus x squared plus x cubed plus x to the fourth, dot, 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 x to the n. What kind of function is this? These are nice whole numbers. Starts with a P. Polynomial.
Oh, that's a very nice.
It is a beautiful polynomial. Is this a beautiful rational function? What happens at 1? This is a rational function. So if I were to look at the graphs of this, because this is where we're going, we're going to take crazy things, Kevin, like 1 over 1 minus x, and we're going to be able to find a polynomial that's equal to that. It's only true, though, for what? X between 1 and negative 1. At 1, I got real problems. What happens at 1? I have a vertical asymptote. Now, so that you'll believe me, I think we should look at the graphs of this. Because if you think about, just stop and think, you believe everything I say, which isn't necessarily a good thing. But, see, I'm from the 60s. We didn't believe anything anybody said. You always had to prove it to me. That, as a vertical asymptote at 1, it's not a nice function at all. Polynomials, they always have these nice bumps, and they're very well behaved. Uh-oh. I'm not going to be able to do it this way. Wait, I can do it this way. My board's slightly off. So let's graph it. Because most of you have 84s, we'll use this. We'll use that guy. Although, it's probably more interesting. After I do the lesson, I'll bring up the cast, and we'll do it on Inspire. Because I get color there. Okay, obviously I'm in the wrong mode because I remember that's the sequences. So I better change my mode back to function. First, we're just going to graph the 1 over 1 minus x so that you can realize it's just not that nice of a function. So y equals, and you could do it with me, 1. And this is exactly what we're doing. This is called a power series. And another word for a power series is Taylor polynomial. They're one and the same, so you're going to get used to those words. I'm going to zoom it 4. So I just want to see what this function looks like. Yeah, it's not a polynomial. There's a break in the graph. So how can I make a polynomial do the same graph? It should bother you that 1 plus x squared will be equal to this. Okay, so I'm going to put that in here. I'm going to do a little circle trace. First, we'll leave the window as it is, and then we'll fix the window. Now, how many terms would you like? I can't do an infinite number. I could type it all in, but I just thought of something. I like it when I think of new things. Let's try that. Summation 2. So I want to go n equals alpha n, and oh, I can't see this. Is that n? That's p. Well, I suppose we'd rather have the n, huh? I don't. I have my context and I can't see it, bro. Above what? Oh, the log. Okay. Now I got to go back to alpha. N is equal to 1. Well, okay, how many terms do you want? 20? I don't know what's going to happen with 20. Let's do 10 because it might take too long. So if you have a new operating system, you can do this. And we're start at 1, right? No, we start at 0. That matters. And this is x to the n. Come on. X. I've never tried this, by the way. This is just... Yeah. Look at, I hadn't had that new operating system when I did it. There's my summation. I will do 10 terms. You'll have to type in 1 plus x squared. Now I'm on the circle trace. You guys know how to change that, right? You arrow over here and press enter till you get the circle trace. Okay, here it comes. We have a lot of terms. It's thinking. There it comes.
Oh man. Oh man. Oh man. Oh, that's our polynomial. Oh man. Watch it be the circle.
Because I set it that way, so you can see it. If I go here, y equals, it's still thinking. I know, because it's off the screen. So y equals. Now, when is it equal to the rational function? When is the polynomial equal? Just between -1 and 1. So why don't we go -2 to 2? Okay, so if you just press enter here, now it's going to be just a circle. I like to leave the trace, but now if I'm on the Inspire calculator, at least you can get color. But there I'm back to the beginning. This shades, that makes it thicker. This shades above, this shades below, and this leaves the trace. Okay, so I'm going to change my window to -2. Let's make it -1.5. Okay, guys, to 1.5. And maybe we should make the y values get bigger. Oh, I messed up. I wanted to do the x, so sorry. That's okay. Let's make this go to 5. Guys. Okay. -1.5 to 1.5. Okay, so here's my rational function. Now you should see the other one coming down. Is it the same? With only 10 terms. Pretty close. You know, e to the x, I can write as a polynomial as well, and we will. Isn't that cool?
Yeah, but it's like, why does it even start?
Because I said it that way. Go back and watch the video I just showed you. There's a circle. I don't know why that's leaving that there. There it goes.
Because it's still thinking.
It's still thinking. Now, I think that's pretty, and I could bring up my cast, and we could do the same thing with the cast. With the Inspire, doesn't have to be a cast, but I can do it in color. At least you can, so you can see them. But I don't want to take your time right now because I can set that up while you guys are working. Okay, now that's just a preview of where we're going. That's what we're going to be doing, finding polynomials. This is one you're going to have to memorize. You don't need to memorize it for this first test, but you will need to memorize it for the subsequent ones. So I might as well start now. Okay, the next part is this kind of a series. This is called a collapsing sum. We need to recognize it. It's one of our convergence tests, and I want to show its convergent. Now, if I substitute in some values, if we put in 1, start with 1, let's just say n equals 1, sorry. So it's 1 over 1 times 2 plus 1 over 2 times 3. Okay, question? Plus, because this is the part that you're going to have to, if you don't pay attention now, you'll have to look it up in the book. I'm not telling you where it is. And 1 3 times 4, and the book is harder than what I'm going to do. 1 times 4 times 5. I can't prove that that converges. I mean, I've got 1/2, 1/6, 1/12, 1/20. My guess is, and if you're on multiple choice, I'm okay with that. Yeah, well, eventually, what has to be true about the end terms here, they have to be going to what for this, that to go to 0. Okay, so how can I actually figure out that that converges? There are only 2 types of problems where you can actually find the value that you can converge to. One's the geometric. So if they say find what it converges to, you know it's geometric or it's this kind. And what I have to do is rewrite that fraction differently. You see, that came from adding fractions. If I have 1 over n times n plus 1, I added 2 fractions, one with the denominator of n and one with the denominator of n plus 1. This is called the method of partial fractions. What we want to is undo what we added, or somebody added. And this is on the exam. Not necessarily in this particular unit. It could be that they'll want you to do an integral of 1 over x times x plus 1. You're going to have to use partial fractions to do it. Yeah. So this, I'm going to teach you how to split this up. Well, I don't know what the numerator was, so I'm going to call that one a, and I'm going to call this one b. Now, pretend those are x's. We could make them x's. It doesn't matter. N stands for any number. I know n has to be a positive number here. However, to figure out what a and b are, I'm going to let n be anything I want. Now, first look at that. If you took some number divided by n plus something over n plus 1, and you added them, the common denominator would be n times n plus 1. So it's called decomposing them. So if I were to add these together, I have to get that. Well, and I could get common denominators and add and try and figure that out. Or I could change the equation by multiplying by the least common denominator. And then I get rid of fractions, because I know how you love fractions. N times n plus 1. If I multiply every term by n times n plus 1, takes a little time to do this, by the way. And then I simplify that. I'm going to end up with, well, what's going to these guys? They cancel. M's over here. The n's cancel, right? So a times n plus 1 plus, as the n plus 1's go, b times n. And remember, n is any number. So you could put n equal to 1 in, and you'll get, let's do that just on the side. If n is equal to 1, then I get 1 equals 2a plus b. And if I let n equal to 2, then 1 equals 3a plus 2b. That's how the textbook does it. And you could solve a system of equations. I'm lazy. And I can't say I was the one that was clever, but I learned this when I was over at the university in my Calc 2 class when I was sitting in a lecture, and the teacher says, well, n can be any number. So I could choose 1 and 2, or I could choose a better number. What's a better number? 0. So if n is 0, then I can do this very quickly. Then I get 1 equals a times 0 plus 1 plus b times 0. Well, what's a then? 1. I think that's kind of cool. So what else could I choose then? Now, knowing that, I want to be clever. What's another number I could try? Why negative 1? Because it gets rid of a. N is equal to negative 1. I know that in my real problem, I can't have a equals negative 1. That's okay. So 1 equals a times negative 1 plus 1 plus b times, what was it? Negative 1. So what's b equal to? Negative 1. If you don't believe me that this is true, well, add these fractions up, with algebra, you can. So that I can take the summation of 1 over n times n plus 1, n starting with 1, I think it was, is equal to a, which was 1 over, which was a over. It matters. A was over the n. And then it's minus b, which is negative 1 over n plus 1. Sorry, it's plus b, but b is negative 1. And we're going to start with n equal to 1. And you're saying, well, what good does that do me? Let's write out the terms now. This is why it's called a collapsing sum. So when n equals 1, I get 1 over 1 minus 1 over 2. N is equal to 2. Guys, if you don't pay attention, you have to figure this out on your own. 1 half minus 1 third. Plus, oh, sorry, wrong kid. I'm thinking of your brother, Brad. Sorry. Who has siblings here? Do you ever get called by the wrong name?
No.
Oh, my mother called me by the wrong name. Okay, that's worse. Okay, what's the next one? 1/3. Yeah, this is homework. Guys, this is homework. Okay. Plus, and you know what? Do I really care about the n terms? Because what you have to do is look at your limiting process, right? Okay, it's what? Plus 1. 1/4 minus 1/5, right? And then I'm going to, well, the last terms will be 1 over n minus, well, I better do next to last one so you see what happens, but it doesn't really matter. It's 1 over, the one before this is n minus 1, and the one before this is n then, and then the last one, and you have to think about that, 1 over n minus 1 over n plus 1. It's what I call the collapsing sum. Almost everything goes away. What doesn't? This goes away. The only way to do the collapsing sums is to write them out. Okay, what's this going to give it? 0. All of these are going to go, and then what's going to go over here? This is going to go, and this will go with the 1 in front of it. So I will be left with 1, all that's gone, minus 1 over n plus 1. And remember, when we do these summations, it's really the limit as n goes to infinity. What happened to the 1/5? The next one goes. That's why it's called the collapsing sum. So what's the value of this? What's the value? 1. This is why I said these are the ones that can be written as only ones that can be evaluated. This is the collapsing sum. It's not geometric. Yes. But I want to stress it is not geometric. So right now, what we have, let's summarize what we have, so I think that's it. Oh no, we have a problem to do. So let's just add a page. What's the first convergence test we have? What should be the first thing you look at? Which you will forget to do, but you should be the first thing you look at. Take the limit of the sequence. This is a sub n. N is equal to 1 to infinity. Does this series converge or not? What has to be true about the limit of a sub n as n goes to infinity? It's got to go to what? 0. If it doesn't go to 0, this must be true for the series to converge. It doesn't make the series converge, but it must be true for the series to converge. So, if that limit is not 0, you are done. If That's what I love. I hope the limit's not 0, because then I'm done. If a sub n is not 0, the series diverges. But if the limit is 0, we know nothing. I'm going to have to do another convergence test. We've only got 3 out of 10. Yeah. That's why we have to take a little break on 5-9 so we can do the integral test. So I have to teach how to do integrals. Let's see, I don't want that. I don't want this. Okay, the second one is if you have a geometric series. What do those look like? It's the summation of, do you remember what those look like? A r to the n minus 1. We'll start with n equal to 1 to infinity. It doesn't matter. It really doesn't matter. This converges to a over 1 minus r, provided the absolute value of r is less than 1. So again, I will look. Well, first I'll look at the sequence. If the sequence is not 0, I don't care if it's geometric or not. It doesn't matter. And then the third one is these collapsing sums. And they look like summation 1 over n minus 1, n plus 1, it doesn't matter. We'll find an easier test coming up, which you'll like much better than this, but right now, we can have that one. The minute I see that on the test, I go, oh, it's going to be a collapsing sum. I'm done, it converges. But they might ask you to integrate that, in which case then you have to do the partial fractions. Oh, you'll see it on the test. Yeah. So those are your 3. And we got more coming. There's 10. Let's see. The rest of them are in section 8.3 and 8.4. We'll split them about in half. What are we at? 7? You'll like the ratio test, and then the other one is kind of a weird one. Okay, so let's do a problem. Ready? Now, what can I do with that 3? I just did this problem. It's this. N equals 1 to infinity of 1 over, oh, I did n minus 1, didn't I, though?
Yep.
So guess what? You're going to do this one, because I don't know what it is. Was it n plus 1? Oh, that's nice, because what was the summation? 1. Plus, then it's this one. What's special about that one? It's geometric. So I'll let you find that one. Somebody can put it up there if they'd like, and we'll find the answer. Oh, I know what the answer to that is. This can be when in doubt, you know what? When in doubt, just write it out. A geometric series is one in which this just grows by multiplying by some number. So let's write it out. Well, let's write it out. This is 1. Let's do that. 1/2 plus 1/4 plus 1/8 plus 1/16. You have to recognize these. It's a huge part of the exam. It's not a little part. It's big, etc. So the formula is a over 1 minus r, provided I recognize that it's geometric. What's a equal to? A equals 1/2. R equals, what are you multiplying by to get here? Not 2. 1/2. So it's equal to 1/2 over 1 minus 1/2, which is 1/2. So what's that end up being? 1. So the sum of this series, of both series together, because you can distribute sigmas, is 3 plus 1, which is 4. So we can look at homework questions if you want, because they're there. Yeah, then you had to skip it because we hadn't covered it. But now you can do it. And then tomorrow, I have you have a worksheet, but we'll work on more problems. So if we want to look at any of the homework out of 8.2. I don't know. I probably assigned them all. So let's look at 8.2. Let's pick some problems. Okay. Starting with 11, determine whether the geometric series, oh, that's easy, is convergent or divergent. Okay, guys, number 11. I don't even know which ones I assigned. Any of them you want to look at in particular? They get hard. 7, the collapsing sum. And 4? Let's start with 4. Okay, those of you who aren't paying attention, don't complain that you don't get it. Let's do number 4. Now, what's the first thing you should always look at? What's the very first convergence test? The limit as n goes to infinity. Why do we spend so much time on sequences? Because you're going to use them right now. Oops. So, what is the limit of the cosine of infinity? Well, it's the cosine of 1, it's the cosine of 2, the cosine of 3. Is it going to 0? No, in fact, it's trapped between 1 and negative 1. I can't even put a value on it. So if this is not 0, this is going to diverge. And you could graph, they ask you to graph it. It says find at least 10 partial sums. Okay, don't do 10, it's way too many. Yeah, that's, otherwise it's busy work. I don't want you to do all that busy work. Graph both the sequence of terms, and you're supposed to be graphing calculator. Now, mostly I'm just trying to look at that piece. That's what I'm going to focus on. Because on the exam, you're not going to be graphing those. But it's nice to visualize them. Number 7 is a collapsing sum. If you write out the terms, you'll see it. So you didn't have to have me talk about it, because it's already written in the right form. Now, let's see. Does one of you want to come up here and do this? Oops. Just drop that. Okay. So just put some values in. Start at 1. So it's 1 over the square root of 1 minus 1 over the square root of 2 plus 1 over the square root of 2 minus 1 over the square root of 3 plus 1 over, when you don't know what to do, write out the terms. Minus 1 over the square root of 4. And I'm going to be left with 1 over the square root of n minus 1 over the square root of n plus 1. What's going to happen to everything in between? Everything's going to cancel. I'll be left with one of those, but remember, when we did the summation, when I say that the summation n equals 1 to infinity is like saying it's the limit as n goes to infinity, summation, I really don't want to start with, well, I'll do it this way, I don't like it, but 1 to n. So what's going to happen when I take the limit of these n terms? That's what? That's 0. So what is this? What's this add up to? All of this goes away. Gone. It's just 1. Collapsing sums will converge. No. You'll find some harder ones. You'll have to split them into the partial fractions. Because what's 1 over the square root of 1? That's all that's left. What happens to this one? Left? N. Oh, yeah, but what happens when n goes to infinity? This goes to what? Yeah. I don't even care what's left. Because it's all going to 0. Should check, make sure that each of these terms in the sequence here goes to 0. More. Okay. Number 8. Okay, guys, try it. I don't remember what 8 is. Hang on. 8 is a collapsing sum. So you know it converges, but you'll have to decompose the fractions. and find out what it converges to. I don't want to do it. How about number, did I assign 9?
Yeah, what's the reason?
You said 1 through 18.
Oh, okay. Let's look at 9. Now you need to be bringing your book. I give you plenty of time, so you should have your book out. Where is it? Doesn't belong there. Oh. Number 9. I like this problem because in the red thing it says that it's actually in the student solution book. Now you guys, if you don't pay attention, you're going to miss this. David, this is not easy material. It is if you listen. Doesn't matter. It says, determine whether the sequence A sub n is convergent. Now on the exam, you have to make sure that you understand if it's a sequence or a series. That's a sequence. A sequence is the list of numbers. The series is adding up the elements in the list. So what does this sequence look like? This looks like n is equal to 1. We always start with 1. So it's 2 and it's 3 plus 1. Then it's 2 times 2 over 3 times 2 plus 1. Then it's 2 times 3 over 3 times 3 plus 1. Okay, that's the sequence. Then what am I going to do with that? By the way, this is 2/4. This is 4/7. This is 6/10. And I don't know what the next one is. Then what am I going to do with these to get the series? I'm going to add them. 2/4 plus 4/7 plus 6/10. Okay, do you see the difference between the sequence, which is just the list, and the series, which is adding them up? The first question is find the limit of the sequence. So I want the limit as n goes to infinity. These are horizontal asymptotes of 2n over 3n plus 1. What is that limit? It's just 2/3. You've been doing this. Same as doing this problem. It's the limit as x goes to infinity of 2x over 3x plus 1. That is all 8-1. This is 2/3. So the limit of the sequence converges to 2/3. Correct? Does the series converge? That's right. The series diverges because the limit of my sequence is not 0. I'm done. I love that one. B says, does the series converge? And it does not converge. The reason why this problem is assigned, the reason why there are so many assigned is because they're all different and you need the practice. When you get to the exam, you'll see something you've never seen, but you'll apply your knowledge. It's like probability. I like this. I don't like probability. But you know that what you have to look for, every problem's different. And I can't say you do them all the same way. So this diverges because the limit of the sequence is not 0. Okay? 10 is explaining the difference between those things. So you have to read that. So what about, should we skip to 11? Now, it tells you on 11 through 18 that they're geometric. On 11 through 18, they tell you it's geometric. So all you have to look for is what? No. These are geometric. And that means they do this. It's a r to the n minus 1. Okay? What has to be true with the absolute value of r? Less than 1. So all you have to do is find r. So 11 is 3 minus 4. And they tell you it's geometric. They're not going to tell you that on the exam. You can tell me somebody. Is that 16/3?
Yep.
Okay. When it gets that little, I just can't. Over 9, isn't it? Okay. You could find out what it converges to, but what is the common ratio? Okay, first off, what's the sign? It's going to be multiplying by a negative. Now, be careful. The first term in this series might not be part of the geometric sequence.
I got it. Negative 4/3.
That's correct. This is not part of the geometric piece. But if I multiply by negative 4/3, that works here, doesn't it?
Right.
So it's negative 4/3. Will this converge? No. It diverges because the absolute value of r is bigger than 1. That's all you have to do. There's not a lot of work. That's 11 through 18. They tell you it's geometric. Find the r values. You might have to separate some. I got some tricky ones coming. It's fun. 13 and 14 are decimal ones. And then after you get there, after you get through 18, 19 through 30, now you have to apply everything you know. You don't know if it's geometric. You have to look and see if it's collapsing. If you look at 19 through 30, do we have any collapsing sums there? I see one. And on 31, I see a collapsing sum, by the way. They call it telescoping sum. I call it collapsing. So you have things to work on. Does anybody need my book? Justin, where's your book? Oh, it doesn't want it. Okay, don't have that much time. So maybe we should let's look at 19, since there's only a few minutes. And if I get time to work, you won't do anything anyway, right? Oh, ask me a question, please. I have to go back and look. You got to come in and get some extra help. But tomorrow morning I have a meeting. I'll have to go back and look. In the meantime, these are quick problems if you see it. How about that one? I don't know what I've assigned, so. Now I'm going to go back and look at 34. What's the very first thing to look for? 34 will take me some time, but I can. Okay, guys? James, what am I going to look for? What's the first convergence test? The limit as n goes to infinity of this thing. This is an easy one if you realize that you have to do that. Marcus, what is it?
1/3.
Okay. What about the series then? 1/3 does not equal what value does it have to be? Because you have to add nothing on at the end, otherwise you keep adding more and more. So this diverges. First test. It's 8.2. It's all 8.2. 8.1 was last week. We can look at 34 from 8.1 if you guys would like to look at that. It's a hard problem. 8? I thought I did 8. Oh no, it's a collapsing sum. Then write out the terms. It collapses. Then it goes away. Now, shh. Do you guys want to look at 34 from 8.1?
Is it not even 1/3?
It's an interesting problem.
Let's try it. Let's give it a go.
How about anybody? It must be other people who didn't get it.
Let's give it a go.
I think we should look at it because I didn't answer this question. Is it anti-third? No. Is it? Okay. Because I have to use the squeeze theorem. And that's another word for that is going to be the comparison test. Okay, guys? I need to know if that's going to go to 0. Because if this is my series, and if this is not 0, if n is equal to 1 to infinity, if that's not 0, I'm done. It's going to be 0. So if it's 0, what do we know? We know nothing. But if this is not 0, I'm done. I don't have to do any of the other 9 convergence tests. This one I'm going to need, I'll just write it down right now. It's the very last thing in 8.4. I'm going to have to do the ratio test because that's where you do the factorials. There are going to be other things we do. We can make it look like a function, but I don't know what x factorial is. It's not a function. Okay, so what I'm going to do is write out some of the terms. So a1 is equal to -3 to the first power over 1 factorial. supposed to be nothing. Negative A2 is negative 3 times negative 3 over 2 factorial. Now, you asked this question, yet you're not paying attention. What's A3?
Don't laugh.
You can laugh, but right now is not the time. What's A3? You have laughing time all the time. Over what? 3 to... I don't think so. Right now it looks like it is. Let's do A4. So it's negative 3. I don't care about the negatives, but... Because now there was a theorem in 8.1 that says if I ignore the negatives and make it the absolute value, if the absolute value equals 0, if the limit of that sequence is 0, then this one is also 0. If it's not 0, I don't know anything. Now what's this? 4 times 3 times 2 times 1. Now, look at these. This seems to be constant throughout the whole thing, isn't it? That's 9/2, right?
Yep.
9/2. And what happens here? This is 1. You can forget the negatives. We don't care about it. And this is less than 1. What is A5 going to look like? When I don't know what to do, this is what I do. I write it out because we can do that. Now, is it okay to just ignore the negatives because they're not important? Because if this works, then the one with the negative sign will work. Okay? It's just 5 times 4 times 3 times 2 times 1. This is still my 9/2. This is still 1. That's just a finite number. And then this is 3/4, 3/5. What's happening when I multiply two fractions? Is it getting smaller or bigger? It's getting smaller. Okay, so let's now make the big jump to n. This is 9/2, but this is going to make it smaller. The 3/5 times 3/4. So I want n of these. So I'm going to do 3 times 3 times 3, a whole bunch of these, etc. All over, and then it's n factorial. So it's n times n minus 1. If you remember, I did a problem similar to this in class. N minus 2. And then this was, let's see, we'll do it this way. 3 times 2 times 1. We've seen that throughout the whole problem, haven't we? And what happens here? These are all fractions. Guess what? Even though, in fact, I'll even do it this way. It's less than, well, this is 9/2. This is 9/2. But this part is less than 3 over n. And then what are we going to do? We're going to use the squeeze theorem. Well, the problem is figuring out what to compare it to. And I said, well, this is always going to be less than 1. And so it's less than this piece here. So let's take the limit. As n goes to infinity, it is trapped by 0 on the side, because these are all positive numbers, which is why I want to use that theorem. Okay, so this is 0. And what's this? Even though it's 27/2, it's 1 over n times 27/2. As n goes to infinity, this is going to what? 0. So therefore, what is that? What's that? Excuse me. What has to happen there? That's a squeeze theorem. When you take tests in my class, even though it's multiple choice, you are going to have to justify it, because my job is to make sure you understand the concepts and the content. And the only way for me to know is for you to justify your responses. On the AP exam, guess all you would like. But once you've done enough of these, you'll realize that n factorial is far more powerful than 3 to the n. Graph 3 to the n, graph n factorial. Oh, you can't do n factorial. You can in sequence mode. And see which one is more powerful. But you got to let n get big. You can't do it close to the origin. It is time to go. I didn't want to talk all hour. Tomorrow we have a worksheet.
We're just having so much fun nuggets, Steve.
Tomorrow we have a worksheet and questions on the homework. Then we move on. But I gotta order those.
What? Yep, we'll work with tomorrow.
I didn't say that.
Hey, Kyle.
They're not announced, remember?
Yes, I could.